This video covers Section 5.1, Exponents in Scientific Notation for Math 95 at LBCC. Our goals for this section are to use the product rule for exponents, learn about the zero power, use the quotient rule for exponents, and learn about negative exponents. We won't actually be covering scientific notation in this section, and as long as you're taking Math 95 at LBCC, the scientific notation part also won't be on your test, so you don't need to worry about it. Before we get started with new stuff, let's remind ourselves what exponents are and a little bit of how they work. In the expression 4 cubed, do you remember what the 4 is and what the 3 is and what that expression is really asking you to do? In the expression 4 cubed, we call the 4 the base and the 3 the exponent or the power. 4 cubed means to take 4 and multiply it by itself 3 times. So 4 times 4 times 4. Then finally 4 times 4 times 4 is 64. So 4 cubed is 64. So exponents are just a mathematical shorthand for repeated multiplication. And by the way, multiplication is really a shorthand for repeated addition. Using that understanding about what exponents are really asking us to do, we can discover some rules for exponents. I want to think about what x squared times x cubed is really asking us to do. Now, that x squared is x times x. It means multiply x by itself twice. And the x cubed means to multiply x by itself 3 times. Now, if you look at what I have here, I've ended up with x times x times x times x times x. That's 5 x's total. So that means take the x, whatever it is, and multiply it by itself 5 times. So x squared times x cubed, when we just get right down to the basics of the definition, it really means the same thing as x to the 5th. This leads us to our first rule. We call it the product rule. It says a to the m times a to the n equals a to the m plus n. Now that's probably not the most easy thing to remember, so I'm going to go ahead and write down how I think of the product rule in words. You might want to take a second and make your own definition, something that you'll remember. Here's my statement of the product rule in words. If two things with the same base are being multiplied, you can add the exponents while leaving the base the same. The important parts to notice here are that we have two things that are being multiplied, that the two things need to have the same base, and that the base stays the same at the end after we add the exponents. The base doesn't change. Now I've got 2 practice problems down here. I'd like you to go ahead and try those. Maybe pause the video, try those problems, and then start the video up again and I'll show you my solutions. All right, you ready to go? Pause the video. Okay, we're back. For this first practice problem, I have y times y to the 4th times y cubed. The things are all being multiplied, and they all have the same base, which means that I can add the exponents. Over here, I've got y to the 4th and y cubed, so that really clearly goes 4, 5, 6, 7. But I can't forget about this lone y over here. There are really 8 y's altogether here. You can always think about something by itself having an exponent of 1 if that helps you when you're adding. On this second problem, I've kind of mixed things up and made it look a little complicated. First, notice that everything here is being multiplied, which means that we can rearrange the order that things are in. The order doesn't matter in multiplication. So I'm going to rewrite this as negative 3 times 5 times x squared times x times y to the 7th times y to the 6th. I still have all the same pieces and everything is still being multiplied. Now it's a little bit more obvious to me which pieces go together. Negative 3 times 5 is negative 15. X squared times x is 3 x's total, so that's x cubed. And y to the 7th times y to the 6th is 13 y's total. So this is y to the 13th. Now that we've discovered the product rule, we're going to play around with exponents a little bit more and see if we can discover any other rules. The first thing I'm going to do is have you calculate 2 to the 4th, and 2 cubed, and 2 squared, and 2 to the 1, you can feel free to use your calculator. And then I want us to figure out what the pattern is, what happens to the number as the power goes down. So go ahead, take a second, fill in that table, and then I'll show you what I get when I fill in the first parts of that table. For 2 to the 4th, you should get 16, 2 cubed is 8, 2 squared is 4, and 2 to the 1st is 2. Do you notice the pattern that happens as we go from one entry to the next as I reduce the exponent here? What's happening? It sure looks like the pattern is that I'm dividing by 2. To get from 16 to 8, I divide by 2. From 8 to 4, I divide by 2. From 4 to 2, I divide by 2. So with that, I should be able to figure out what the rest of these are. 2 divided by 2 is 1. 1 divided by 2 is 1/2. 1/2 divided by 2 is 1/4. I'm going to show you the scratch work over here. 1/2 divided by 2 is the same as 1/2 multiplied by 1/2, which is 1/4. Now, this gives me a couple of ideas for how the 0 exponent and the negative exponent might work. The 0 exponent rule says that anything raised to the 0 power is 1, as long as that thing is in 0. But don't worry, we won't usually ask you a trick question like that. You can just remember that anything raised to the 0 power equals 1. We saw that anything raised to the 0 power is 1. Now let's go ahead and look at those negative exponents. If you flip back in your notes, you'll see that when I had something raised to the negative power, that was the same as 1 over that thing raised to that power. Or, to go the other way, if we have 1 over something to the negative power, you can move it upstairs to change the sign of the power. In words, I like to say, when you move something from one side of the fraction to the other, you change the sign on the exponent. So if it goes from the top of the fraction to the bottom of the fraction, the exponent changes from negative to positive, or from positive to negative. And if you move it from the bottom to the top of the fraction, the exponent changes either from negative to positive or positive to negative. Now I've got a bunch of practice problems using the power rule, the negative exponents, and the 0 exponent. This would be a good time to pause the video, try the practice problems on your own, and then come back and see if we get the same answers. Are you ready? Go ahead and pause the video now and work on these problems. And we're back. Now I'm going to show you what I got and how I did each of these problems. For 7 to the negative 2, I thought about this as being 7 to the negative 2 over 1. If it helps, you can always take your expression and put it over 1 so that you can see both sides of the fraction. Then I moved the 7 downstairs, which changed the exponent from negative 2 to positive 2. This 7 to the negative 2 leaves behind a positive 1 on top. 1 over 7 squared is the same as 1 over 49. So there's my answer for the first one. For this second one, I did something really similar. I had negative 3 to the negative 4, so I moved the negative 3 down into the bottom of the fraction, which changed the sign on the exponent from negative 4 to positive 4. Notice that the sign on the negative 3 didn't change. Only the sign on the exponent changed. Once I had 1 over negative 3 to the 4th, I took negative 3 to the 4th power and got positive 81. So overall, this is 1 over 81. For this third problem, it's really easy if you remember that rule that just about anything to the 0 power is 1. So 254 to the 0 power, that's 1. For this one, 1 over 3 to the negative 2, I moved the 3 from the bottom to the top of the fraction to make the exponent positive, which gave me 3 squared. If it helps, you can think about the fact that the 3 squared left behind a 1 in the bottom. 3 squared, though, is just 9, and 9 divided by 1 is still 9. So my answer here is 9. For 5x to the negative 4th, I thought about that as being over 1 so that I could see both sides of the fraction. Now the 5 doesn't have a negative exponent, so it can stay up there in the top, but the x to the negative 4th needs to move downstairs to make the exponent positive. So it goes from being x to the negative 4 on top to being x to the positive 4 on the bottom. For x squared times x to the negative 7th, I decided to start by using the power rule. I added the two exponents together, 2 plus negative 7, to get negative 5. Then I took x to the negative 5 and moved it downstairs in the fraction to get 1 over x to the positive 5. So we did use both properties there in this problem. For x to the negative 5 times y to the 0, I also have to use more than one of the rules that we've learned. First I said y to the 0 is just 1. So now I have x to the negative 5th times 1. And then I thought about that whole thing as being over 1 so that I could see both sides of the fraction. And I moved the x to the negative 5th downstairs, leaving me with 1 on top and x to the positive 5th on the bottom. Okay, we're almost done. We have one more rule. At the beginning we said one of our goals was to learn the quotient rule. So that's what we're going to do now. I've got here x to the 7th over x squared. I'm going to write out exactly what that really means. X to the 7th means x times x times x times x times x times x times x. 7 x's. On the bottom, x squared means x times x. Now let's use what you know about fractions and canceling to cancel some things. If I've got a bunch of x's being multiplied together on top and 2 x's being divided on the bottom, I can cancel out one of these x's with one of these and one of these x's with one of these. And that leaves me with a total of 5 x's on top, right? 1, 2, 3, 4, 5. So that's x to the 5th. And on the bottom, I'm left with a 1. Just like when we cancel things when you're doing fractions. So this is just the same as regular old x to the 5th. All right, I bet you can see that there's a shortcut that we could have used. We didn't really have to write out all of the x's and then cancel. You could have just subtracted the 2 from the 7. So, yes, we could have subtracted the 2 from the 7 to find out that x to the 5th. So that, of course, leads us to our quotient rule. If you have a to the m over a to the n, that's the same as a to the m minus n. I'm going to write that out in words over here. You might want to take a moment and write this out in words that you'll be able to remember and understand. How I might say this in words is, if you're dividing two things with the same base, you can subtract the exponents. You'll always do top exponent minus bottom exponent. There are a couple of things that are important to remember here. First of all, the two things need to have the same base. Otherwise, we don't combine the middle. And the other important part is that you always want to do the top exponent minus the bottom exponent. The order matters here since we're doing subtraction. Finally, we've got 2 practice problems with the quotient rule. You might want to pause the video and try these and then come back and see how I did them. Are you ready to look at how I did these 2 problems? For y to the 6th over y squared, we simply subtract the exponents, 6 minus 2, to get y to the 4th. This second one is a little more complicated. I started by doing all of the exponent subtraction stuff, and I left the 10 and the 15 alone. So I left the 10 on top, the 15 on the bottom. A to the 7th over a squared, I can subtract exponents. 7 minus 2 is 5. For b cubed over b to the 9th, I can subtract exponents. 3 minus 9 is negative 6. Now I'm going to start simplifying this even more. If I have 10 over 15, I can reduce that fraction to 2 over 3. And then I've still got the a to the 5th and the b to the negative 6th in the numerator. Finally, I'd like that b to the negative 6th to actually have a positive exponent, so I move it to the downstairs part of the fraction, which leaves me with 2a to the 5th over 3b to the 6th. I'd like to take a moment to point out that this isn't the only way to do this problem and end up with the same solution. You could have first noticed that the 10 and the 15 can be reduced to 2/3. If you have 7 a's on top and 2 on the bottom, and you cancel, you'll end up with 5 a's on top. You could have noticed that if you have 9 b's on the bottom and 3 b's on top, you can cancel 3 and end up with 6 b's on the bottom. You don't have to go through the process with the negative exponent if you don't want to. However, it's one way to make sure that you remember that the b's should end up on the bottom and not on the top. That's it for section 5.1, but we'll be looking at more exponent rules in the next section, section 5.2. See you then!